Okay, a few videos ago we looked at this distribution, which is the sampling distribution for about 600 students who each would take a random sample of size 5 from our times list of top 100 movies. And remember that each individual point in this histogram is a single average of movie lengths for the 5 movies in that student's sample. So we know a lot about this distribution. For example, we know that the population mean is 119. We can calculate the standard deviation of this sample, or of this distribution, sorry. And we know that it follows a student's t-distribution with degrees of freedom equal to 4, which is what we talked about in the last video. Now let's do a little thought experiment here, and this is an important one. Let's say that someone comes to us and says, hey, I've taken a sample of size 5, randomly selected movies from some population, but I'm not going to tell you which population. And your goal is to see, do you think that this person's sample is coming from this distribution of movies, from this population of times top 100? And the next thing is they tell you that it's right about here, 164 minutes is their sample average. So they're not even telling you the individual lengths of the 5 movies, but they are telling you that when they averaged them, they got 164 minutes. Now you look at this and you think it's a little bit shaky. So first of all, you know that most of the sample means will be here in this range between, say, 95 and 145, 150 minutes for the average out of the 5 movies. So when they say 164, you're thinking, it doesn't seem very likely, but at the same time, it is possible. Look, when we had 600 sample means, there were some that were even below 70 and some that were definitely above 164, these few out here. So not likely, but possible. The question is, at what point is it so far away from our mean that we think, yeah, it's not very likely that your 5 movies were from our population. Your 5 movies may have been from a completely different population of movies. Like I said, from all the German movies ever made, all the Russian movies. We see that it's a pretty high length here, and somehow in my mind I think of Russian movies as being quite a bit longer. So the question is, how do we decide whether or not it's coming from our population or another population? So let's give these populations names. Let's call this population that we've been dealing with, the times top 100, our null hypothesis population. So again, we know a lot about this null hypothesis distribution, but there also may be other movie distributions, and we're going to call this our alternative hypothesis. Again, this is the same as our research hypothesis that we talked about a couple weeks ago. And this alternative hypothesis, if we are really coming from a different set of movies, we don't know much about it at all. So it could be that it's sitting right here like I drew it. It could be over here. Whatever the case, the question is, do we think that this 164 sample mean came from the null hypothesis, or did it come from an alternative hypothesis? In statistics, we can do all kinds of things with the null hypothesis. The alternative hypothesis, the research hypothesis, remains a mystery. That's why we say we reject the null. We don't usually say that we find the alternative hypothesis to be true. And in essence, anything we're doing with inferential statistics is based on what we feel about the null. We never know the probability that the alternative hypothesis is true, no matter how fancy the math we use is. That's just beyond what humans can know. But what we can know is the probability of getting a result this extreme, or even more, if this null hypothesis is true. In other words, if their movies really did come from our times 100 list, what's the probability that we'd get a 164 or even more extreme than that? So to do that, what we're going to do, essentially, the concept here is we're going to set up two critical values. And I want to be careful how I draw it here because we don't know what this critical value is at this point. But if we get something lower than this critical value on the left or higher than this critical value up here, what we're essentially saying is that it's too far away from the null hypothesis. It's too many standard errors away. We just don't think that this is very likely. So we're going to assume that, yeah, it could come from a different population. We're going to reject the claim that it comes from this null hypothesis population and conclude that there's some evidence that it comes from this alternative hypothesis population. But all of this depends on where that cutoff value is. Specifically with this 164, is it coming to the left or to the right? Is 164 in this rejection region over here, or is it in the region that is plausible that we could get if that sample really did come from our 100 movies? So let's go back to the what we were looking at in the last video here. We had the population mean, the standard deviation, standard error, and we created a confidence interval. What turns out, this confidence interval is precisely these cutoff values. So 76 and 163. If we go here, it looks like I was a little too generous there. Let me make a different color here. So 76 right here is what the rejection region really should be. This is my critical t-value. And 163. So right here, 163. And so what I'm saying is I'm willing to take a 5% risk. 5%, no more, no less. That's my risk of making a type 1 error. Now what's a type 1 error? A type 1 error is rejecting the null even though it's true. In other words, it is possible that I could have gotten these 5 movies from the times list of 100 and still got an average of 164. It's possible, but it's unlikely. So I'm going to reject it knowing that I could be making a type 1 error, but I'm willing to take that chance because I'm 95% of the time my sample means are going to fall here in this area. So because it would only be this extreme, this green area extreme, 5% of the time, I'm saying that this is too unlikely to come from the null hypothesis population, and so I'm going to reject the null hypothesis and conclude that there's evidence for the alternative hypothesis. Now, where does the p-value come in? So I went through all of that. I used a confidence interval there to create this rejection region, but I never calculated a p-value. So let's go back to the sheets here and look at how I would create a p-value. Okay, so I have one question I want to answer first. How many standard errors am I away from the mean? Now keep in mind that I was told there was an average of 164. So 164 minus the population mean, this would give me how many units I am away from the mean, 44.83, specifically raw units, or minutes to be precise in our case. But we want to know how many standard errors that is. So if each standard error is 15.7 and we're 44.83 minutes away, what I would want to do is divide by standard errors to find out that I'm 2.85 standard errors away from the mean. So what kind of p-value would that give me? Well, here's where I can use the t-distribution. I put in the number of standard errors away from the mean that I am, the number of degrees of freedom, which we've looked at as 4, and the tails, we're looking at a two-tail test here, because we don't know which direction it would be away from the mean originally. And we would get a p-value of 0.046. We know that our alpha level, our significance level, is 0.05. That's something that we set up right at the beginning. And so because our p-value is less than our alpha value, our alpha level, we're going to reject the null. Notice that this is the same decision we came to using the confidence intervals, right? Using the confidence intervals, we knew that from 76 to 163, we would not be able to reject the null. We would fail to reject the null. But anything less than 76 or higher than 163, we would have rejected the null. And indeed, we did reject the null using the confidence interval, and we did reject the null using the actual p-value. So, and this will always be the case. You can always use either one of these ways to figure out whether or not the specific sample statistic that you're given is going to allow you to reject the null or not.